All right. Good morning. This is Thursday, July 10th, 2025, Fanshawe College, ELEC 1013 Network Cabling course. Week 9. Well, time flies fast. Week 9 out of 14. Okay. Seems like it's a nice hot summer. So a couple things before we start. Let me bring up the course plan here. Here's week 9 or week 8. Oh, July 7. Yeah. So, no, week 9. Yeah, it is week 9 now. We're still going on through the test. The test has been shifted a little bit to this week. So just remember to complete the test before tomorrow, Friday, July 11th, by 11:59 p.m. And there will not be extension dates for this test. All right, so that's one thing. What else we have here? Today we're going to finish up previous class. This was the last slide that we finished on when we had the class in person. So just as a review from that last slide, these are the categories of the cables. Cat5, which is quite obsolete right now. However, you still are going to see some of the old installations using Cat5. And in some cases, Cat5 is not going to, as they say, cut the mustard. Because in some cases, and I'm not going to say what, but some devices are not going to work on Cat5. Cat5e will be the minimum for certain devices. So when you are retrofitting some equipment or installing new equipment, you got to make sure that the wiring that the client has currently at the time that you're doing it, that the client has Cat5e wires. And if you see the old Cat5 cabling still being in use, then before you quote the price or do this, complete the survey and present the survey, which is basically going on site, doing a site visit and seeing what's what and what's needed to be done, and making notes, then you have to make sure that the client knows that the wiring has to be replaced before they can make a decision whether to hire you or not to do that certain job. Other things such as types of switches that have PoE or not might have to be considered. Some of the decision making has to sometimes has to go around the type of switches that are being utilized. But that's kind of getting ahead of ourselves a little bit right now. And so here's the gauge of the wiring. So Cat5e, Cat6, and so on. You see Cat5 and Cat5e, they use 24 gauge of the conductors. And Cat6 and up, the wire gets thicker and the twist gets tighter, more consistent, and more twisted because Cat5, Cat6. Do we have that picture right here? Yeah, here's an example of Cat6. Cat5e will not have this separator. Bring on the, oh, here, there you go. Oh, there it is. Here's the separator. Cat6 will have that separator, and Cat6 and up, actually. Cat5 and down will not have this separator. And you see the pairs are twisted, and the pairs are twisted at different rate. The purpose of the twist is to eliminate the crosstalk, so the magnetic field cannot build consistently enough in order to affect the other pair. So if the magnetic field is scattered around because of the twist, not straight cable, it's a twisted cable, twisted pair, then the magnetic field will not have the consistency and enough power to bleed itself onto the other pair. And if the other pairs are twisted at different rate, then there's even less of a chance of signal bleeding through or creating a crosstalk between the pairs. And cat 6 and up, not only they have the cable not only has the pairs twisted at different rate, every pair has its own groove in that separator, and the separator is twisted as we go along. So it is all the whole object of this whole thing is to eliminate the possibility, or so-called minimize the possibility, of a crosstalk. And twist, believe it or not, was invented, the idea was thought of Mr. Alexander Graham Bell in the old days when the telephone was invented. So the problem was already addressed then. All right, now we talked about shielded, twisted pair, and so on. And that was the last slide. So we talked about transfer speed, which is how fast the bits are being transferred in the cable. And this is the upper limit of the speed. So how fast can we transfer the bits in the cable so the signal is understood on the other end of the cable? Maximum length, you could see 300 feet is the maximum length that you could have with category cable, with annotation to that, and I'll get to it in a second. Here's the bandwidth, and this is what kind of a frequency or carrier frequency. If you don't know what carrier frequency is, I would strongly recommend that you review that idea. I'm not going to get deep into that right now because we got to carry on with the lesson. So this is how high the carrier frequency can be transmitted through the carrier, or actually signal. Any kind of signal with any frequency can be transmitted through the cable and still being understood on the other end. So you can see the bandwidth can be different than the transfer speed of the bits. Right? Now, as a reminder, when we talk about the speed of the signal being transferred through the cable, we're talking about bits per second, megabits per second, gigabits per second, not bytes, bits. All right. Now, when it comes to storage, we're talking about bytes. So that hard drive can hold up to 1 terabyte. Okay. And there's no per second because it's just storage. Now, transfer speed is in megabits per second. Quite often, when it comes to telecommunications, there's a tendency of saying how many megahertz, because it's just so you could say 1 gigahertz, but you would more likely hear 1,000 megahertz, okay, instead of 1 gigahertz. It's just the way the technical jargon has set itself within the environment. But that's not a rule written in stone, just so you know. All right. So continuing from last lecture, this is an RJ45 plug. And this is how we count the pins. You see this RJ45, RJ stands for registered jack. Not going to get into the history of why is it called. We already talked about that. Am I recording? I think I am recording. I hope I am recording. Yes, I am recording. Okay, good. Just a little mini paranoia that's set in my brain here. All right, so this is how we count the pins, the prongs, from left to right. If if you stood that up, and you would have that latching clip away from you and the prongs facing you. This is how we count the pins. Here's pin 1, 2, 3, 4, 5, 6, 7, 8. It has 8 pins. It is to accommodate 4 pairs, and one pair has 2 conductors, so 4 pairs will have 8 conductors. All right, so now 1, 2, 3, 4, and 5. These are the middle pins. And just as a reminder, a telephone signal, POTS telephone signal, always is going to be, line 1 is going to be on the 2 middle prongs. And most of us remember that by now. Now, this is how we count the pins. And of course, remember that dance, blue, orange, green and brown. So blue, if you're looking at the way we were holding that jack or plug in the classroom during our lab. So it's going to be blue, orange, green, and brown. That's the dance that I showed you. So here's the picture of the pins. See, pin 1, 2, 3, 4, 5, 6, 7, 8. All right. Here is pair 1. Okay. That's how things are. There's a solid. Here is the stripe. Pair 1, blue, orange, green, brown. Remember, this is the configuration A, right? Or not? Yes, it is. Blue and orange goes around pair 1. And then here's green, pin 1 and 2, and 7 and 8 will be the brown pair. All right. The type of signal, you could see, okay, tip and ring, tip and ring, tip and ring. The terminology has carried through from years ago. So there's transmission data and receiving data, plus and minus, positive and ground or negative reference of that. So you could see Cat5e. This is Cat5e. You could see that pair 1 is not connected, so blue is not connected, and brown is not connected. It's not used. All right. Now, that's up to Cat5e. Cat5e only uses orange pair and the green pair. And some of them are going to be transmit and receive pins. Which is transmit, which is receive? Well, that depends on which end you're looking at of the cable. This is Cat5e. Some less expensive cables, patch cords, you're going to see with just those green and orange pairs, and the blue and the browns will not even be there. This is Cat5e, straight link. All right, now, which is transmit, which is receive. NIC stands for Network Interface Card of a medium-dependent interface. Now, NIC, Network Interface Card, that's the port that is on your laptop, your PC, and whatnot. Now, hub or a switch, that's the other port. So this is how they transmit and receive pairs. If you're interested, this is how they're arranged. So from your laptop or PC, the green is the transmit pair. And on the switch on the other end, that is the receive port terminals. And of course, goes the other way, signal goes the other way on the other pair. So that's how they transmit and receive are being solved. Now, excuse me, when it comes to a crossover configuration, let's say you need to connect two laptops together or two PCs together. Those ports are going to be wired the same way. So on this pin 1 and 2, these are the transmit terminals on laptop number 1. And pin 1 and 2 also are the transmit terminals on the other laptop. We're not connecting, in this picture, we're not connecting laptop or PC through the network cabling to the switch terminal in the LAN room, but we're just connecting two PCs together. Sometimes for some reason you might want to connect that. Then you need to use a crossover cable, because if you connect transmit to transmit, you're not going to have any communication. The transmit pair has to see the receive pair on the other end. So you need to flip the greens and oranges in order for the communication to take place. So that's why sometimes you need to create a crossover link. Where else would you have crossover link? Well, sometimes the switches give me a couple seconds here. Let me start something up. I just want to explain to you where else. I'm looking at the chat lines. Robert says yes. Connor says yes. That's been a few minutes ago. I apologize. Firing up my board. Here, yeah, good. All right. So where else would you use a crossover? Let's say you have a huge equipment rack, all right, 19-inch rack. Yes, I know. I was supposed to use shift to make straight lines. Here's the rack on wheels, all right? Equipment rack, standard 19-inch rack for the data equipment and for the audio and so on. It's an industry standard 19-inch rack. Let's say you have a switch in the equipment rack. All right, let's say you have the patch panel with all the ports. That's the patch panel. Patch panel. All right, so all the field wiring goes in there. And there's another patch panel that is capable of, let's say this one here is capable of 24. And there's just 24 connections and so on. And then we have a switch, which is a traffic controller, to put it in the simplest terms, that also has, here's a switch, okay, which is sort of like a, as a traffic controller for the Ethernet signal in the local area network. And let's say this one has a 24 port, okay, port switch. And there's another switch that is also a 24 port, okay. So all these cable, all these connections are going to be patched into each an individual port. Let me just change the color. So so these guys here are going to, yeah. These guys from that one are going to this on one-to-one basis. Each an individual PC or whatever smart device is going to have its own connection to the patch panel, and from that is going to have its own dedicated port on the switch. Now you see what's happening. We have two switches, all right? and they need to act as one. So sometimes, let me see if I can choose different color here. So sometimes you're going to have to connect one switch to another. And then it could be another one switch, then connected this. You could have more switches. So when you connect those switches in their dedicated connecting ports, they're going to act as one giant switch. 24, and so on. Now, in some cases, some of the old switches, it is going to be specified, depending on who makes it, what brand it is, and whatnot. You're going to have specifications or instructions telling you which type of patch cord you're going to have to use, either a straight link or crossover patch cord. And you need to give it that way to that switch. The newer switches right now, most of them are made with those ports, those connecting ports. Those ports are equipped with automatic sensing circuitry. So if you plug in a straight patch cable, it is going to sense that a straight cable was plugged in, and it's going to adjust, and it's going to start communicating. If you plug in crossover, it's going to sense that you have plugged in a crossover cable and the patch cord, and it's going to start communicating. So that's the newer ones. Some of the older ones, or maybe there is some on the market that needs to be addressed in a certain way, installed in a certain way. So it's going to ask for either crossover or straight link. So you need to know your equipment if you are going to set up a network, but this is not the object of our class. Our class is the cabling infrastructure. I just want you to know that something like that exists. So if you're connecting things and something doesn't work, there's a little bit more information, more knowledge for you to utilize if you're troubleshooting certain things. When it comes to, because sometimes you're going to connect things, not necessarily configure. That's the IT configuration department that is going to do that. However, sometimes you might want to get additional courses in IT department that we also offer in our college. Then you're going to be the full-featured type of a network person that is able to install anything, any kind of network from scratch. It takes a little bit to accomplish that type of knowledge and experience, but I've seen people like that. Usually I do the network infrastructures, and I'm teaming up with a person that does the IT configuration, and we're creating a great team. And hey, we can go. Usually it takes two people to install anyways. Things, pull wire, install the wiring. So that's usually that type of collaboration that you might expect to accomplish if you want things to work properly. And once you accomplish that type of a teamwork, then, as they say, the world is your oyster. It's a cliche type of saying. However, I'm going to tell you, there's a lot of business to be made in this type of field. All right. And that's all I'm going to say about that. All right. Now, see, remember this screen that actually this is in 2025 in our network cabling class. Right now, we're doing that crossover link. So right here, you could see with Cat5E that we're doing that the blues, pin 4 and 5, are going straight. The browns are going straight. And if you compare this picture and that picture, you're going to see that the oranges and greens are being switched around in order to make a crossover link. In some data testers, when you press the test button, it's going to enunciate that the link has failed because it is testing for straight link. But it is telling us how is it that it has failed. So if you want to make a crossover cable, it has to fail, the connection has to fail a certain way. And there's a little indicator here on the bottom left of the screen that says T568 type of configuration, A to B crossover link. All right. So it has failed, but it has to fail in a certain way. All right. So that's actually right now, this week, we're doing this lab. Okay. Cool, eh? All right. Now, when you Google crossover data link or some sort of that thing, okay, you're going to see, sometimes you're going to see this type of picture where you can see the oranges and greens crossed over, and you're going to see the blues here and the browns going straight through. And the picture is going to be labeled a crossover data link or something like that. But when you have multiple pictures displayed, you're going to also see this type of a picture. When the oranges and greens are crossed over, but also the blues and the browns are crossed over. And you're going to think, well, what's going on here? Because those two pictures will be different, and both of them are going to be called crossover links. Did somebody make a mistake? Did somebody give us wrong information or whatnot? There's a reason why those cliche timers exist. If it works, it works. Yes, Robert. So, excuse me. So what's going on with those two pictures being so different, and they're both labeled as crossover Ethernet link? Well, let me solve the mystery for you. No, it's not a mistake. What you need to know is that up to Cat5e, as we were talking about that, only oranges and greens are being used. So in order to make a crossover link with Cat5e, only up to Cat5e, then you only need to cross the oranges and greens. Now, with Cat6 and up, all four pairs are being used. Blue, orange, green, and brown. So in order to make a crossover cable with Cat6 and up, then you have to cross over the oranges and greens, and you also have to cross over the blues and the browns. Okay? Mystery solved. Here are the references and so on. And that was the end of that previous class. Now, let's get on to this thing here. Here's the bread and butter of this week. We looked at the network topology before. And usually this network types and network topology, I usually have it during 1 week. But this time I had to separate those two topics. Nevertheless, you're going to get the same information. So let's talk about network types. You're going to be, okay, pardon me for saying that, you're going to be or not. That's your whatever lifespan is going to take you, whether you're going to find yourself a job in this field or not. However, since I'm doing this class, I'm just going to, without the need for further explanations, let's just say that I'm going to assume that you are going to get the job in this field, just to save time so I don't have to explain that every time I say it. So you're going to find yourself in the infrastructure installations world. It's not just and as you'll be able to see in further lectures that we're going to have, it's not just running a cable from one end to another and terminating it at both ends. The technician position in this type of world involves that. Yes, it involves running a cable from one place to another and, terminating it. But it also involves installing equipment, configuring the equipment with the help of a support desk of something that's called a level 2 support. And level 2 support are the people who will have the knowledge of this particular network that you're working on. And they will know the passwords and all the access ways and all that stuff. And sometimes you're going to have to tap into some piece of equipment with a laptop through Ethernet port or a console cable with the older systems or whatnot. And you're going to have to call up a command prompt, usually command prompt, or through the web browser, you're going to log into maybe a modem or through command prompt with some other equipment. And you're going to have to punch in some commands while being on the phone with the level 2 support. And I see, Robert, even without doing this as a career, I would say knowing it at least on some base level with what is networking. Yes, basically in this world, at this day and age, another cliche saying, you can't escape having to do something with that. Even if you are not a networking technician, you're still going to be put in situations that you will need this knowledge. It makes just that much more fun when you're doing this thing and you know what to do and you actually get paid for it. That makes that much more fun, let me tell you. All right, so let's go to network types. Definition again, computer network is a group of computer systems and other computing hardware devices that are linked together through communication channels to facilitate communication and resource sharing among wide range of users. Networks are commonly categorized based on their characteristics. Network types, we're going to look at the local area network, wide area network, wireless local area network, metropolitan area network, SAN, which has different acronyms, storage area network, system area network, server area network, or small area, pretty much the same thing, different name. Virtual private network, VPN. And here's a picture that I took. I think that was the LCBO store that I was, it was a new installation that was in Niagara on the Lake, as far as I remember. You see, I'm asking you to take pictures, and that's not because I want you to take pictures. I had to take pictures when I was doing installations, when I was working in service, long time ago, but not that long. So look at this here. This here is a gateway device. That the gateway is having all the permissions, restrictions, and all kinds of information of how the network is supposed to communicate with the outside world. And the gateway is usually connected to a modem. All right. Now, modem is the one that converts the analog signal to the Ethernet type of signal, analog to digital. Modem is the modulation and demodulation device. So you combine those two words, you get modem. All right, I keep repeating that. Now, when it comes to having a dedicated gateway where all the protocols, permissions, and restrictions, and all that whatnot are being programmed here, then the modem does not need to have that programmed in. So usually what happens when you do that type of installation, you're going to have to put the modem into something that's called a bridge mode, which means if the modem is not in the bridge mode, just a regular type of configuration, you're going to have a connection from outside, whatever it is. Is it the DSL? Is it a cable or a coaxial cable? Or is it a fiber optic? Whatever the modem is made to receive from outside. But on the other side, it's going to have Ethernet ports. And you can connect PC to it right away, and you can have the communication with the outside world. Now, when you put into the bridge mode, the signal is passed straight through the modem. So the modem's job is just to make a connection with the service provider and pass the signal through raw. And all the programming is of how the network is supposed to communicate with the outside world is solved is programmed into the gateway. Why is this thing being done that way? Well, if there are large chain stores, it is so much easier for the engineers who are designing the network to just have one common gateway and distribute that to all the stores and have that whatever modem it is going to be. Because in one town, there could be a certain type of service provider. In another town, there could be another. So there could be millions, not millions, but could be a lot of different service providers. And if engineers had to, or the data, the IT people, if they had to accommodate every single programming for every single type of service provider, that would create quite a mess. So the solution is have the modem in bridge, so the modem connects to the service provider, and that's all, and passes the signal through, and all the programming about the network is done in the gateway. So what lights can we see here? Well, you can see the OK light. That means, I guess, at least one thing is okay, whatever that means. It's an OK light. Now, here is the when. So when you fire up, that was always an exciting moment when firing up the network for the first time after everything is connected. So connect the modem makes a connection with the internet provider, all right? Then you're looking at some lights because this thing's going to go like disco lights because it's configuring itself, booting up and whatnot. This is the first light you're looking at. Bang, that thing comes on. That means the gateway has made connection with internet. Then some of those lights, LAN, local area network lights, are going to be lit up depending on how many devices are connected to the Ethernet ports on the other side of that. So just shows the communication maybe with some switches or hubs or whatnot. All right, and then those lights come quickly. They come on quickly. And then there's that moment of truth. It takes a bit for that light to come on. So you're waiting and biting your nails in all that excitement to see if the VPN comes on. Boom, the VPN comes on. All right, so you can tell by these lights here that the gateway has made a connection with the internet, and also it logged on or logged into the virtual private network that is dedicated to that particular business. Local area network connects a group of computers in close proximity within the same facility. I wrote it down myself. My mom didn't help me. Usually it will be a building or a group of buildings or such. Local area network, small. comparing to other networks. The purpose of local area network, LAN, is sharing resources and devices such as files, printers, applications, email, or internet access. Simple. That's what a local area network connection would look like. Here is the LAN equipment, network equipment. And of course, things are connected in a star configuration. Everything home runs. Every single jack has its place on a patch panel. Patch panel is patched to the switch or whatever the equipment has to be. And that's basically, in the simplest terms, that's what local area network looks like. LAN parties, the holy grail of the gaming. Okay, in the 90s. All right. One network can consist of multiple LANs working together. So it will be sub-LANs. Like, for example, in one local area network, the network can be divided into accounting, production plan, management, offices, and whatnot. These different departments can be on different LANs within the same company. What would be the purpose of that? Well, there could be certain type of data traffic going back and forth within the accounting department, and you don't want those data signals to go through the whole common network because that would just slow things down. Production plan and so on. So sometimes it is to our advantage to kind of subdivide some of those networks, but that could be part of the huge local area network. The other thing that I would see would be, like, for example, there would be a subnet going through the office computers, and then there would be another separate switch that would take care of the security cameras. So that's another example of dividing one LAN into some kind of a little sub networks. Local area network connects a group of computers in close proximity within the same facility. Well, that's what we said that. Now, I just took a Google picture of a couple of buildings. I don't know what these buildings are. I just found two buildings so we could pretend that we're talking about these two buildings belonging to the same company. Okay. And this here, I guess that would be some kind of like a tree or something like that. So let's say these two buildings, because they're physically separated, but they belong to the same company. Right? Well, there would be one main demarcation point in either of those buildings. So the main signal has to come in somewhere, either to this building or to that building, and there will be a room chosen to be working as a LAN room. All right. But we want these two buildings to work as one LAN. So here are some solutions that you might encounter. Let's say these two buildings are supposed to be one LAN. You could dig a trench and run fiber optic line. Well, you could dig a trench and have a bunch of data lines going, copper cables, but that would be a lot of cabling going through underneath. Not a very efficient solution. So usually a trench could be dug, conduit could be installed, or something that's called direct burial cable can be installed underground. And of course, it has to be a certain depth and whatnot. Usually we don't do that. We request other companies to dig the trench, or some bigger companies, they have a department that does that. Dig a trench, run a fiber optic, but here lies the challenge. Over here in this let's say this is the main building and the LAN room is somewhere here. All the Ethernet traffic uses Ethernet protocols using copper cables, Cat5e or Cat6, to deliver the signal from the server to each individual PC, for example. Well, fiber optic line is not a copper line, it's a glass. It's a glass medium transmitting light signals. So you see what the problem is? Two different environments. Oh, sorry. That's where I'm going to introduce you to the term that's called media converter. Sometimes it's referred to as media player. It's pretty much sort of the same thing. But let's concentrate on the term that says media converter. Now, where is my board? There's my board. All right, so here is a server. Here's another server. It will have a bunch of patch panels, bunch of switches. This one will have a bunch of patch panels, bunch of switches, and maybe somewhere on the top part, usually, would be the media converter. I'm just going to put media converter MC, but don't quote me on the acronym. I just don't want to write the whole thing. Now, if this is a fiber optic line going between those two media converters, then the media converter, this media converter, is going to have to convert the electrical signals into light pulses, and this one will have to receive that and convert it back to electrical signal, so the network continues. And if there's any data going this way, then this media converter, and we're going to have to convert the electrical signals into light, and this will have to understand that and translate it into, so one link, fiber optic link, will have transmit and receive type of a line going on. So it'll be two strains of fiber optic. If you want to have more data throughput, then you consider another pair. So this type of media converter converts electrical signals into light. There is no one type of media converter. You use a media converter, the one that you need for the specific job. You could also have a wireless link going between those two buildings, and that's also a popular solution. It takes less, sometimes it's impossible to dig a trench underneath when things are already going. When it's a new construction, you can plan this, but if it's already things existing, sometimes it's difficult to dig. So it is possible to do a wireless link. The only problem with the wire, not that much of a problem, it has to be line of sight. So if there's a tree between that, it has to be trimmed down. Sometimes if the snow covers things, you might have a little bit of outages or whatnot. So it's a wireless thing, right? So this type of media converter will have to convert the electrical signals, the Ethernet signal, into radio waves, modulate them, and this one would receive that modulated signal, demodulate it, and basically transfer it through. So this PC doesn't even know that this whole operation has happened. All he cares about is that it's communicating with the server. So this type of media converter would convert the electrical signals into radio waves. Now, I'm going to continue with this lesson here because I don't want to I don't want to cut into the next week. So if you have to go, as I say always, if you have to go to another class, please go. If you can stay, if you want to, you can stay. But I'm going to continue recording that. When I post it, you can catch the end of this one, okay, later on at your convenience. Now, LAN cable structure example. What did I write here a few years ago? Not all the networks are up to the highest standards. Some service calls will look like this. Well, what do we see here? Do we see a patch panel? Yes, we do. This is an improvised patch panel right here. It's a quadruple surface mount type of a jack assembly. How many links do we have? 1, 2, 3, 4, 5, 6, 7. Small business. Now, from that improvised or pseudo patch panel, there's the field wiring. See, you just can see a little bit of that. These are the wires that are going to the PCs. Now, from here, you have the patch cables connecting each and every individual port on one-to-one basis to a switch. Well, there's not a fancy equipment rack on the floor, but the equipment is there. And here would be a gateway, and here would be a modem, or this would be a gateway, and this would be a modem. Now, it's not a fancy schmancy type of a setup, but in some small businesses, that's all you need. Now, I would install this thing a little bit in a different way. Look, the zip tie is not even trimmed, and there's a bit of a mess going on. But that's what the client has. And they called you to do whatever needs to be done. So you're not going to say, oh, you know, I have seen better networks. No, just be nice to the client, because you know what? The money that you get for the service call is just the same if it were a different type of environment. The money is just the same. And guess what? There are a lot of situations like that. You can't ignore it. Significant amount of situations like this, that's how you make money. Right? So sometimes you're going to get into this type of environment. Be nice to the client. Always. Treat the client that has a huge $1 million setup, treat that client like a king. When you go to this type of client, when they have a small setup like this, also treat them like a king. All right? That's how you stay successful in business. Now, some of the situations you're going to encounter, now that's an exaggeration, but you may. Some of those environments will look like this. Now, I just took a picture of the internet. This is some kind of a Google data center that was publicly available, and I'm just using it for our references. Do I have the references here? Yes, I do somewhere. Now, what I want you to consider is the power that is supplied to the equipment. There's a heavy power going on. A lot of power is going on to supply this. The power, when these devices are powered up, they generate heat. How much heat? They generate a lot of heat. In fact, if the air conditioning unit was not working, because this room has to be cooled down by an air conditioning unit, big time. If the air conditioning unit fails, this whole data center would fail within 5 to 10 minutes, to the point that the equipment would be deemed useless. That's how much heat This whole, you would not be able to walk in and work here. That's how much heat would this thing generate. So the power, I'll just say, comparing this thing to a barbecue running. So one of the rack or two racks is compared of heat generated by a barbecue basically running. So how many barbecues do we have here? And let's say the air condition doesn't work. So just so you know, there's a lot of power that is drawn by the equipment, and a lot of power has to be spent on cooling the room down. The other thing I want you to kind of look at when you're looking at this image, look, there's a lot of equipment. A lot of equipment. Here's a bunch of copper wiring, and you can see there's some wires, interconnection, and maybe some field wiring going that way. But there's some trays, wiring trays, cable trays, and they're quite empty. They're available, but not too filled up. And over here, you see those plastic protective conduits for the fiber optic lines. And over here, where's the rest of the wiring? Well, yeah. Okay. I was talking about the power. Now, look at the floor. You see this type of floor? It's a very expensive floor. Well, it's called a raised floor. Just like the tiles in the ceiling, you get tiles in the floor. Just like that. Expensive floor. But look, you have those tiles and you have the whole grid. It's called raised floor. And it just makes sense in some cases to have that. Some big guys can afford it. Whenever you have to work on that, you're going to ask the facilitator for those suction cups. Those floor tiles are heavy. In order to lift them, you need those suction cups. Whoever takes care of this room, whoever is walking you in there, then you are going to, they're going to know where those are. So I've heard servers that can suffer from vibrations. Yes, there are some servers can suffer from vibrations if it's near the train station or otherwise machinery present. That's when it comes to data and some of the fragile equipment. I know there was one recording studio in London on Rectory Street, EMAC recording studio. And I was in my younger years, I did record a couple of songs, but they was in the old location in 1987. But the EMAC studio is on Rectory Street, Rectory and Dundas. There's that building standing there. And that building, when it was built or purchased and revised, it is sitting on a bunch of cushioning just for the purpose of dampening any kind of outside sounds that could interfere with the audio recording in their studios. So it's sitting on a pile of sand and then some more cushioning things. So there's a building within a building over there. So yes, vibrations do play a role. Hey, here's a birdie. WAN, wide area network. WAN joins an unlimited number of smaller network. And if you remember one of the first slides of this presentation, there was a connection to WAN. WAN joins an unlimited number of smaller networks in a way that the devices of different networks can communicate with each other, different networks. Basically, that's what it is. The internet would be a wide area network. So that's the biggest network, unfinished, never-ending network. So that would be WAN. So when you see the connection on the equipment that says when, that is basically the connection to the modem, which connects you to the internet. Like, for example, here, LAN or WAN, I'm not sure if you can see it. So sometimes when you get the so-called box from the internet provider, it will have the modem, gateway, and the switch in one box. So the part of the modem here is DSL, digital subscribers line, which is the internet signal superimposed onto a telephone line and just plugs in with a telephone jack right here. That thing is going to sense that. And this is going to act as a modem. Or instead of using that, you could use that one, port number 1, and connect that to another modem. So you have some options on this one here. And over here, if not, if you're using just a DSL, you got 4 available LAN ports, local area network ports. So basically those can be plugged into. Just wait. Okay, somebody picked it up. Thank you. All right. So you could have the options of plugging in 4 devices. You can plug in 4 PCs, 4 laptops to it, or you can plug in a switch that will give you more ports. There's a reset button. Here's a power button. Okay. Wireless local area network. That's a very popular thing these days. As the word wireless suggests, this is a type of LAN that uses wireless network protocols to establish communication between devices. Is it possible to have a complete 100% wireless network in the most residential? You could say that, yeah, I have a complete wireless network. But even the wireless access point has to be wired. So technically, yes and no, right? Or say, is it possible to have complete, or is it that the wireless LAN can be a part of LAN? So some of the links, like a not wireless, but Ethernet link or Ethernet connection, Ethernet, which means Cat5e or Cat6 wire, it can be connected to a PC, laptop, some other device, or it could be connected to a wireless access point. So then you have a situation where you can plug into the network with the Ethernet cable, patch cord, or you can log into the wireless Wi-Fi network with the same, with your laptop, with your cell phone. In our school, you have those options. Usually people use, well, you're not supposed to use the Ethernet ports because it's part of the network, but we do have a lot of these in our building. In fact, we are covered with these. Maybe they look slightly different, but they are actually Cisco, which is the king of the, but there are other ones that are good ones as well. Because this is like $1,000, one of those. And our Cisco devices in our school, you could see a blue light or a green light in there. If you know what to look for, you're going to see where, like, usually every classroom has 1 or 2 of these to get a good coverage and good data throughput, not because one can't cover the area, but one can only handle so many connections at a time. So sometimes there are 2 in a classroom. Right? And you can see if there's no one in the classroom and you walk in there, you're going to see a green light lit up, which means it is ready, but nothing is connected to it wirelessly. And if you are on school network with your cell phone or your tablet, it is going to find you. If you're logged in, it's going to find you. It's going to log on to you and the light is going to change to blue. That's how these Cisco ones work. Different ones could have different type of lights arrangements and whatnot. But if you just walk around our school, that's how you can tell our devices. Excuse me. And if the light is flashing, that means there's maybe some error, or maybe something was reset and is booting up. Can you spot the wireless access points mounted around our hallways in our school? Presently, wireless access points have status lights, and I already explained that to you. All right. Here's another way of using the wireless devices. There are a bunch of PCs or whatnot in the conference room. They could be wired into the network, local area network. And there could be a couple of wireless access points in the ceiling. So maybe there are some people come here with their laptops and tablets, or maybe some guests and whatnot. Metropolitan area network. A network spanning a physical area, a large physical area. And here's a definition of what spanning means, okay? Larger than LAN, but smaller than WAN. Well, WAN is the biggest. That's the internet, the whole internet. And this will be larger than LAN because LAN is one company, type of thing. Such as a city. A city would have its own metropolitan area. So it's like a blown up LAN, but it covers the whole city. So all the traffic lights and maybe some security cameras or the speed traps or whatnot, they could be connected to the metropolitan area network. And they will be working together. A MAN is typically owned and operated by a single entity, such as a city or a township or whatnot. Some references. Okay, let's go on that one. SAN. We're almost done, guys, here. System area network, or sometimes it's referred to as a storage area network. Links high performance computers with high speed connections in a cluster configuration. Whoa, here's a mouthful after a mouthful. Also known as a cluster area network. Storage area networks, and this is kind of an example of that. It's a complicated picture, But let's say there is a school board. And the school board has one main building that is the administrative building somewhere in the city. That's all the main offices for the whole school board. All the big wigs go there, and they manage the whole school board. And usually they have a large IT department there that are handling the whole IT service for all the schools, high schools, elementary schools, and the offices. And they handle all the personal data for the payroll and also the whole thing. So the data is quite crucial. What happens if, God forbid, the building burns down, or there's some kind of a tornado that just sweeps through and things are destroyed? So does it mean that all the data would be basically deemed useless, lost? No, because within, let's say, I know that's how things work in like school boards, for example, but it could be banks, could be other institutions, hospitals. That crucial data is stored in more than one place. So in one of the high schools, in the LAN room, there could be a server dedicated to copy the data that is already in the main building of the board office. And it could be more than one locations like that. So that would be considered a storage area network. So if something happens to one building, some whatever, you still have the data available that is stored in maybe 5 different places. And I just gave you the example of a school board. but it's pretty much every large corporation that does it. Fire department, police department, hospitals, banks, whatnot. It's a normal thing to do. Another example of storage area network would be something like this. That's on the consumer level. And the storage area network, of course, you would have restrictions and permissions of who can access what type of data. So the accounting people can only access the accounting data. That's what they need. They don't need some other data because some other department takes care of that, and so on. But that's on the corporate level. On the consumer level, maybe you are using that without even knowing it. Let's see. System area network, storage area network, which is what just I was talking about. It could have different accessibilities. Accessibility to servers, direct or indirect, conditional accessibility to certain end clients. So you might make certain type of data available to certain type of people based on whatever criteria. The end client might access send data subject to conditions. So basically, that's what I just explained to you. Right? Now, on the consumer level, let's see some example here. Well, let's take a look at the local television service provider. All right. Video on demand service. And I'm still haven't seen a cent because somebody used my picture. Well, advertising. I haven't seen a cent to it. Yeah, right, okay. I'm funny. See? Yeah, there you go. Example of a signal path for the consumer level. Here is a happy family gathered around a television set, all dressed up, and they're watching a television programming. How is the signal being transferred to them? Well, the television set is connected to a TV box, which is a media converter, or sometimes it's called a media player. Why is it called media player? Well, it could be a local to a television set. Or all those menu boards at McDonald's, Burger King, Tim Hortons, and all the fast food places and whatnot, those menu boards at the back above the people who are serving you. Those are also connected to the network. And there used to be, they would have external boxes called media player connected to the network, and there will be a video output connected to that. So that like regular flat screen TVs used to be used. But now things are a little bit different. Technology has gone up a little bit. So there are dedicated menu boards being produced, and they have a built-in media player, or which is the media converter, which converts the data signal into the video signal. So those are the signal that those menu boards get is from Ethernet cable. That's it. They get the Ethernet connection, boom, and they're plugged into the power as well. That's all. So, but this is a box, the TV box media converter or media player. Now, that thing connects to a modem of their network, internet, LAN, internet network, and that goes into the cloud. Now we go to the cloud and we shift to another, where does this cloud is connected to? Well, it is going to the signal routing system of a local TV service provider. And this is this could be something that's called well, there are different names for it, but one of them is media retrieval rack. So if though that happy family that is there, they requested watching a movie with me famous actor, right? um, specific title of the movie, and they, let's say they pay $6 or $10 or whatever it is for that movie to watch. They have access to that specific movie based on the payment, and there's a media retrieval rack that has all the movies stored on it. And these are SCSI drives. These are pictures that I took while having some personal tour over one of the local television providers somewhere. These would be like a bunch of SCSI drives having all the information, programming, TV shows, movies, and so on. A lot of it here. Here's magnification of that. Like, for example, that was some years ago. So this rack contains 230 hard drives. And this is all hard drive. So hard drive, here's a hard drive, here's a hard drive, full of movies. Each storage drive would be 1.8 terabytes. So here's 1.8 terabytes, look. So people can order the movie. So that's also another, on the consumer level, the usage of SAN or storage area network. Right? Then comes the virtual private network, VPN. A secure or virtual created within the internet, a tunnel, quote unquote, tunnel between two or more devices. Yeah, more than two devices. So let's say a huge department store that has stores in every city. They need to have some sort of a data flow between those stores and the main sort of a computer frame located somewhere in the world. Mm-hmm. So a virtual private network can be created to which only the stores or facilities that belong to that corporation have access to. And that's it. So it's just like dedicating a part of the internet access to just that one company. VPNs are used to protect private web traffic. Blah, blah, blah. So in a way, it makes it look like one huge local area network, but covering the whole world. As far as there could be a company, XYZ company in London here. There could be another building that belongs to the same company in Kitchener. There could be another building that belongs to the same company in China or in India or in Switzerland. And they both belong to the same company. So you can make them log in to the same VPN and they will work almost like a LAN, like local area network. The question, would the raised floor have to do with reduction in that the vibrations? No, it's just to save space because they can. Right? Large corporations use VPN technology like to link facilities, which is basically what I explained. All the other servers like Skype, Netflix, well, Twitter now, X, Google, or they all belong to the same network. In retail, banking, and whatnot, they are logging in to their own VPN. So they're all connected through a secure connection that nobody can get to, just them. And it's part of the internet. And there's some pictures that show that kind of stuff. Let's say there is a company that owns 1, 2, 3, 4 buildings, and one building is in Canada, the other one is in Africa, or South America, Africa, and there's one in Asia. and they all belong to the same VPN. They are logged into the same VPN. And let's say they have a VoIP telephone system installed in all of those. And that VoIP telephone system logs into the same VPN network, to the common VPN. Well, if it were not VoIP, just a regular conventional telephone system, if that office, the person in that office wanted to call the person in that office, they would have to select an outside line, make a long distance connection with long distance charges, and then local lines would be employed there, and that connection would be made. With every minute, a long distance charges pounding up on them. So the communication would be just only if necessary, right? But if they have VoIP telephone system, and the VoIP telephone system is logged on to the VPN, the common VPN, then there is no difference between that person calling this person next to the office next to them, or that person calling that person right here, because it was just like dialing an extension number. It's just like dialing the person next door. No difference between here and here and here and here. No long distance charges. It's just like using internal type of a call. That's what VPN does for us. So there's big savings on money. Can we exist without internet? There's a bit of a question here. You might want to watch that funny little clip. It was just meant to make you smile. Can we exist without internet? It's a philosophical question. We existed for thousands of years. Can you imagine? That's another question. Can we imagine existing without internet? I can, and some of us can, because I remember the time when there was no internet. But now we have gone so dependent on it that, yes, if it vanished now, the world would go insane for a while, and then we would adjust. And but there will be a lot of miserable people missing the internet. All right. Okay, that's it for today. We have gone over some time, 22 minutes. That's the longest I've gone over. But we are all caught up right now with all the materials. So thank you for your attention, and I will see you when I see you next time. Have a wonderful rest of the week. Thank you.